What we're going to be looking at for the video today is synthetic division. This is another method of dividing polynomials, and in many ways it's a lot easier than long division. The drawback is that it only works for special types of division. So synthetic division works, for our purposes we will say, when the divisor is a binomial with leading coefficient 1. Now, long division will work with division of any two polynomials. So that's really handy. This synthetic division works in a much more specialized scenario. So let's say that we want to do this division problem, for example, and pursuant to the conditions I mentioned on the previous screen, our divisor is a binomial, two terms, and the leading coefficient, the coefficient of the x, is 1. So we can do synthetic division here, and we set it up as follows. So here we have it set up. The negative 3 comes from our divisor right here. It comes from the fact that when x is negative 3, this term is 0. So you're always going to ask yourself, what makes this term 0, to figure out what goes in your box at the top left here. And then these numbers here are just coefficients from our dividend polynomial. So that's how we're going to set this up. So the way we start is we start by bringing this first number here straight down below, 6. And then what we're going to do is we're going to multiply negative 3 by 6, which is negative 18, and that comes up here. Then we're going to add. Now, in long division we were subtracting, but in synthetic division we're going to add and say negative 5 plus negative 18 is negative 23. And then again we're going to multiply negative 3 times negative 23. We'll get positive 69. And we're going to add and get 63. And this 63 will be our remainder. So just as with polynomial long division, if you've done this, you've done all of the hard work, but you still need to tell me what your answer is. And the way we read this is, it's actually easiest to read this from right to left and say, okay, we've got a remainder of 63, so that's 63 over x plus 3. This term right here is going to be our constant term, so we'll have negative 23 plus our 63 over x plus 3. And then since negative 23 is our constant term, 6 will be our linear term. So we'll have 6x minus 23 plus 63 over x plus 3 will be our answer to this synthetic division problem. So that synthetic division problem went a little quickly, you say. Well, we will try another example. So this example will really illustrate what a powerful tool synthetic division is. This is a long division problem I've got to work with here. But it's actually going to go really quickly with synthetic division. So first I'll look here and say, okay, x minus 6, well that's 0 when x is 6. So I'll put that in the box up the top left. And then I'll just put my coefficients in. 1 is the coefficient of x to the 4th, negative 3, negative 28, 59, and 6. And I bring down my 1 to start. 1 times 6 is 6. 6 plus negative 3 is 3. 3 times 6 is 18. 18 plus negative 28 is negative 10. 6 times negative 10 is negative 60. Negative 60 plus 59 is negative 1. And negative 1 times 6 is negative 6. And 6 plus negative 6 is 0. So again, I've done all the hard work here, and I just need to figure out what this means. Okay, I've got no remainder. So I've got my constant term is negative 1. My linear coefficient is negative 10, so I've got negative 10x. Then my quadratic term has got a coefficient of 3, so that's 3x squared. And my cubic term has a coefficient of 1, so I've got x cubed. So what that's telling me is that this whole thing up here divided by x minus 6 results in the polynomial x cubed plus 3x squared minus 10x minus 1. Isn't it nice how easily that works? Now we do have some of the same concerns with synthetic division that we did with long division. Namely, that the dividend here is not in standard form. So I need to write it in standard form. Okay, x to the fourth minus 2x cubed, and I'm missing my x squared term, so I need a plus 0x squared plus 3x plus 1 divided by x minus 3. And I'll set this up, 3, and I've got 1, negative 2, 0, 3, 1. 1 comes down, 1 times 3 is 3, negative 2 plus 3 is 1, 3 times 1 is 3, 0 plus 3 is 3, 3 times 3 is 9, 3 plus 9 is 12, 3 times 12 is 36, and 36 plus 1 is 37. Now I went through that pretty quickly, but I'm expecting you're going to be getting comfortable with it at this point. So remainder 37, that's 37 over x minus 3. I've got a constant term of 12, a linear coefficient of 3, so 3x, and I've got an x squared, and I've got an x cubed. Alright, so that's about all the instruction I'm going to do on synthetic division, but there's one additional application of that process that we'll take a look at now. So the synthetic division process is also really helpful if we have a question like the one below. I've got a function of x that's a polynomial, and I'd like to evaluate that function for a given x value. So I've got f of x equal to x cubed minus 4x squared plus 5x plus 1, and I'd like to know what is the value of that when x is equal to 3. So yes, we could go through and plug 3 in for every number and use our order of operations carefully to evaluate, but we can also use synthetic division to get an answer for this a little bit more quickly. So I set up my synthetic division problem here, and whatever value I wanted to evaluate the function for is what I put into the box at the top left. So I put a 3 in there, and I go ahead and bring down 1. 3 times 1 is 3, and negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 5 plus negative 3 is 2. 2 times 3 is 6, and 6 plus 1 is 7. And in synthetic substitution, all I actually care about is this remainder. So my remainder is 7, and that means that f of 3 is equal to 7. So again, when we're doing synthetic substitution, there's no changing of signs like you're sort of used to in the synthetic division process. We just say, okay, I want to know what f is when x equals 3. I put in the 3 up here. So that's all of our instruction on synthetic substitution and division, and I'm just going to give you a couple problems to prepare for class tomorrow. Here are your problems to prepare for class. The first one is very straightforward synthetic division. The second one is almost as straightforward, just a few more terms. And in the third problem, you're going to use synthetic substitution to determine the value of the function when x is 6. Please prepare these, and I will see you tomorrow.